launch satellites to orbit Earth and capture solar power, and that avoids the need to build massive power plants on Earth and deal with cooling, because cooling is actually much easier in space than it is on Earth. You can just radiate to the vacuum. And so what we're proposing here and what we intend to do is to try to climb the Kardashev scale to, be kind of like a respectable civilization. So when the aliens, hopefully there are aliens out there, and they maybe finally decide to talk to us, where we have some respectable amount of the sun's energy being used.
Yeah.
That's not like totally pathetic, which is the current situation.
And so before we start sending data centers, sending all of this to space, there are some limiting factors that we got to get through that would traditionally make it so like this is almost impossible.
Yeah, what does it take to scale?
Yeah.
So things it takes to scale are you need to have a large mass to orbit capability, which is what Starship will give us. That large mass, so you ultimately need to send millions of tons to orbit and beyond, and you need the power associated with that. So if you want to put 100 gigawatts or ultimately a terawatt into space from Earth, you will at some point need a terawatt of solar, and then you're going to need a terawatt of AI chips. So the three things you need are mass to orbit, a lot of solar power, and radiators, of course, and a lot of chips.
All right, well, let's start ticking down the list. So mass to orbit, that's where Starship comes in.
Yeah.
We just had first flight of V3. It was awesome. I know you were there. It was crazy to see that rocket launch.
Yeah.
And like long time coming. What's Starship's kind of purpose of being? What is it going to be doing?
Yeah, so Starship is going to revolutionize space, really. It's the first rocket design that is capable of full and rapid reusability. Now, reusability is the fundamental breakthrough that is necessary to make life multiplanetary, as well as to ascend the Kardashev scale. You simply cannot ascend the Kardashev scale unless you have a reusable spacecraft, and you cannot extend life to the moon, to Mars, and to the rest of the solar system without a reusable rocket. The cost is simply prohibitive. You can't make enough rockets.
Yeah.
Unless you can refly them. Just like any other mode of transport, you can imagine that if we had to throw away airplanes every time we flew, flying would be far too expensive, and basically no one would be flying airplanes.
You're doing a whole lot more driving.
Rapid reusability.
Yes. Every mode of transport is reusable, without which is simply not viable as a transport system. So cars, planes, boats, horses, bicycles are all obviously reusable.
Yeah.
With rockets, it's much harder to make a rocket reusable because Earth has a deep gravity well and a thick atmosphere. And these make it just barely possible to achieve reusability with a rocket. And there have been many prior attempts to create a fully reusable rocket. And most of those attempts have been abandoned partway through because they didn't think they could succeed. In order to achieve full reusability, everything's got to be perfect. The engines, the structure, the avionics, the choice of propellant. You've got to go to extreme measures for mass optimization, which is why we have the tower catch the rocket instead of putting on landing legs, which are heavy. The rocket can simply be caught by the tower. And we haven't achieved full reusability yet, but we do expect to achieve that hopefully later this year with Starship. And then you've got to achieve full reusability. Then you've got to go a step beyond that, which is make it rapidly reusable, such that the rocket lands, it gets caught by the tower, gets put back on the launch stand, and can be flown again without any refurbishment or laborious inspection, like an aircraft.
Yeah.
This is incredibly difficult. This is the first time that there's ever been a rocket where that is possible. That's what makes Starship so profound. I mean, it also happens to be the largest flying object ever made, the heaviest flying object ever made, the most powerful moving object of any kind. Starship V3 is more than double the thrust of the Saturn V moon rocket. By version 4, we'll be pretty much 3 times the thrust of a Saturn V moon rocket. And we expect Starship to be flying more than once per hour down the road.
One of the fun facts from Flight 12, that was actually the heaviest payload SpaceX has ever flown. And that's still just a fraction of what V3 can do. So,
yes.
I mean, once we're flying massive amounts really rapidly, I mean, we already fly the majority of payload to space with Falcon. Do people even really understand what mass to orbit becomes once Starship is flying?
It's many orders of magnitude greater than what is the case today. So even with Falcon 9, Falcon Heavy, SpaceX delivers almost 90% of all Earth mass to orbit. I think we're somewhere between 85 and 90% right now. And then most of the remaining mass, I think, is launched by China. And then the rest of the world, including the rest of the US, is the remaining, 5 to 7%. Now, with Starship, we'll be aiming to go from somewhere around 2,500 tons a year to orbit to millions of tons per year to orbit. And to do so at a pretty short period of time. So we think probably we can get to 1 million tons to orbit per year in about 3 years, thereabouts.
Starship is going to take care of the mass to orbit limiting factor.
Yes.
And then power generation. So first, and Ian, maybe you can help. People probably struggle to visualize a little bit when you say